Hello everyone and welcome in today's video. Today we are continuing with the virtual work method and let's continue to describe the task for today where according to the exercise we have to determine the displacement and slope at point C of this clamp beam from one end, and we need to use the method of virtual work. It is given that E, EA, and GA is constant for all the members, and the secondary moment of the cross-section is given as shown here on the figure. So for member A to B, let's say cross-section is a bit different than the rest of the beam. And according to the task description, we need to account for bending, axial, and shear. Also, it is mentioned that at point B or a joint B, the connection is assumed to be rigid. Therefore, we are going to have one continuous beam as a cantilever beam in this case. So without any further ado, let's continue to show the solution for this beam. And as the beam is already determinate, it's easy for us to determine the support reactions by using the three equilibrium equations which we know, where if we start with the forces on x direction, the component AX is going to be 0. Continuing the sum of forces on y direction, AY is going to be 0. If we take bending moment at point A, we're going to determine the bending moment at point A, which is going to be equal to m. Now, the next step to be done is to find the functions on those places where we have discontinuities on the beam, and I decided to continue from the last part. I took the cut section in this direction and determined the bending moment functions according to these boundaries as we see here. Next, let's continue with the virtual work, and at the point of interest, which is point C, according to the task description, we need to find displacement and rotation. So let's first start apply the bending moment of 1 kilometers at the end. And as we did on the previous exercise, we need to determine the support reactions, and we just use the equilibrium equation for that to get the following reaction forces and bending moments for virtual beam 1. Next, we need to find the bending moment function as we did on the previous case, and this is going to be the result which we are going to obtain for this cantilever beam where we apply 1 kilonewton meter moment at the end. Next, as we need to find also the displacement, we need to apply a vertical load at the joint of interest, which is joint C. And in the same manner, we are going to determine the support reactions by using the three equilibrium equation as we did before. And here you can see the results for that. Next, we need to calculate the bending moment functions for this case as well. And we take this cut from the end and we determine the following bending moment functions, shear functions, and also the normal force functions. Next, let's continue to determine the rotation at point C, and for that we can use the integration, and these two components are going to be 0, as for this case the axial forces and the shear forces are going to be 0. Therefore, we continue to calculate the rotation at point C by integrating, and we are going to have that this is going to be the rotation at the joint C parametrically. Next, let's continue to define the displacement at point C, and in the same manner, shear forces and normal forces are going to be 0. Therefore, we use the integration and find the displacement at point C, which is going to be as shown here. Now, these two values are parametric, and in case if something is going to be changed, like lengthwise, we can use this one in order for us to determine the rotation and slopes. One thing to be mentioned here when doing the integration, we must be really careful when using these cross-section properties, as for example in the boundaries from 0 to 2a, according to the task from 0 to 2a, which is here, this cross-section has a different value of I. Therefore, we need to be really careful to take this into account in order to have the correct result. Next, let's continue to assume some values for A, the bending moment at the end, and let's assume some values for I and the E value in order for us to have some values for which we can compare with the software and make sure that what we did or what we calculated by hand is correct. And if we put these values into the parametric values which we found, we are going to obtain that the rotation point C is going to be 0.024 radians, and the displacement at point C is going to be 149 millimeters. And this beam was modeled in a finite element method software, Autodesk Robot. And after we applied the loads, we were able to generate the results. And as it can be seen here from this small table at node number 3, which is assigned here according to the software, we had that the displacement at point C is going to be minus 149. This is with minus sign indicating the downward position, and the rotation is going to be 0.024 radians, which comes to say that the result which was obtained by hand calculation was correct, and the formulas can be used in the future if there are some parameters which are going to change for this type of cantilever beam. So this concludes today's video. I really hope you enjoyed today's video, guys. If there is any questions, please leave them down in the comment section below. Thank you very much. See you on the next video.